Hello. Today I'm going to talk to you about Zeppelin. The massive airships that used to fly the skies, and they were quite magnificent. And the idea was so successful that Empire State Building's antenna was designed to be able to moor Zeppelins next to the Manhattan skyline. They were, however, built with a huge tank of hydrogen. So putting any spark next to it was a high risk of combustion. And today, we're going to do just that, put a spark next to a Zeppelin. Hello, good afternoon. I'm Michal Goszczyński. I work for Adobe Consulting Services, where we are often asked to go through digital transformation projects, and that usually entails an upgrade, a total redesign, some sort of a massive refactoring of the code base. And as a part of that, often questions are being asked like, how many components are used on our pages? How many times each component is used? And when you start to get the answer for those questions, you dive deeper. Okay, but how many of those components are used on this language, are used on this site? And the same goes for assets, like which assets are used? I mean, how many assets of my dam are used on these pages? Are the assets only from that folder used in this site, and that there's no cross-contamination? And then also we want to start grouping those results by our sites, sections, and languages, and our own abstractions. And that's not really a difficult question to ask if you're a developer, because you can create a script or some quick application that will crunch the result, run some query maybe, and answer some specific questions that you're going to ask, like count components, count pages, and maybe even count them by some regions that you have. Apart from the fact that if you run a query that will return all the components used and all the assets used, it's probably gonna fail. There are some other issues with the approach, like it has to go through a full dev test and release cycle if you want to get a data from production. And if you're in a highly regulated environment, that's a feat on its own. It will only answer the questions that you've asked in the very beginning. So if you just ask simple questions like count me the number of components, then that's easy. If you start grouping them by many different factors, then that gets complicated very, very quickly. And finally, writing such tool kind of feels like reinventing the wheel again, because you're looking at the list, and then that list gets iterated, and results are collected into some other list. And there are better tools available that already do that for you, and you don't have to write that code over and over again. And those tools are Apache Spark and Apache Zeppelin. So Spark is an analytics engine which allows you to ingest some random data without any schema or apparent structure, and just discover that structure with some internal magic. And the AM structure is somewhat like that. There are some pages, there are some subpages, and they're constructed of components. There is some structure to it, but not a whole lot. So it's a good tool to make sense out of this data. However, it's a backend engine, so it's nice to have some sort of a front end. And I'll show you Zeppelin for that, which is an interactive notebook. And in analytics world, the notebook is just a piece of different scriptlets that you can run, and you can run some bit of a Python or Java code or Scala, and then next to it in another notebook you could write some SQL queries against the data that Spark has crunched and discovered the schema, and allows you to discover it. So those tools together will give you a nice interface for crunching the data that you take out of AM. But now you have to get that data out of AM somehow. And we know that query doesn't work. So what I've done is I've used a good old repository traversal. And as I traverse through the repository, I print out the data that are interesting to me. So if you want to have information about my components and assets, and around how they're used on the pages, then obviously we're going to get a resource type of the node that we're currently iterating over. which page does it belong to, the page replication status, last modified date. And if we found any reference to the assets in its properties, then we're going to print this out as well. How to traverse the content efficiently? Slink has an abstract resource visitor, which is great for this kind of a task, where for every resource we have to do some action, and it's a visitor pattern that is to be applied. All we need to do is extend that class and implement the visit method. And in that visit method, for every resource we're going to visit, we're going to print out the interesting properties if they are there, present. So we're going to print the resource type, we're going to print the path, and some others, which I'll demonstrate later in the demo. How to use that class later on? Obviously, we need some entry point to this class. So we're going to write some servlet that will instantiate the newly created visitor object. It's important to pass to that visitor somehow I'm passing the response, but you should pass at least the output stream for your servlets, so that when you traverse and create your JSON objects, you automatically print them out so that the memory footprint is very low. And the last thing you would do is to call the accept method, which provides an entry point to the traversal, and then every node under every resource after under this site is going to be traversed using resource list children method. As an example output, if we find a component node, then it's going to obviously print the current resource path, what is the resource type, some information about the page, and some information about the component using the component manager API, if that resource type maps to a component. And sometimes it might not. For instance, you could install a content package, but that particular instance might not have a application package for this content. And if you find an asset reference anywhere in the properties, then obviously the file reference property is going to be printed out, and as well information about where that page is. I mean, where on the page and on which page this asset has been used. This traversal isn't as bad as it sounds. You'd think it could be causing a lot of performance problems, but I've done a quick test, and I've created a site with 10 million pages. The repository was about 30 gigabytes in size. I mean, 60 initially before the garbage collection has started. But my EC2 instance, M5A extra large, with a disk that had 1,000 IOPS. IOPS in AWS is the number of read or write operations you can do per second, and that counts in a 256 bytes increment. So you're allowed 1,000 on the volume that I have provisioned, and we can see that throughout the process of the extraction, that has been around below 40. The spike here is when the online compaction kicked in, actually, and there's a little spike in the write operations. But the overall process took about 38 minutes. The CPU usage wasn't big either on that instance, and obviously a little spike during the compaction. But the impact is not so significant. It takes time, obviously, to go through all the nodes and read all the properties, but it's not a terrible impact. As it comes to memory usage, it was flat in a JVM monitoring, so I'm not including that. There was no impact on memory whatsoever, no noticeable, at least on the graph. Now, how to set up Apache and Spark together? It's very easy. You can just put a Docker image. There's a Docker image ready, so all you have to do is to run this command, share two folders, one local repo where we're going to put the files that we have extracted from AM, and the notebooks is just a data where Zeppelin stores those little snippets of that we are going to with queries and little codes, and it's available on your local host port 8080 as we've specified in here. So now let's see how that looks in action. I've got AEM running and I've got already the Zeppelin started up, and I'm just going to show you quickly just going to call the extraction element. It's very quick. It just printed out the JSON for We Retail in well under a minute. And I've got this file saved in a file here already. I've done that for We Retail and I've done that for Weekend Site, which are freely available to download. And now let's go to Zeppelin. So this is what happens when you open Zeppelin, your homepage, and you can create any nodes, just being the name. I've got one created for adaptTo as well. And here are all the nodes that I've prepared just to go through them in 30 minutes time. To load the file that we've just extracted, we're just calling Spark read JSON, and we're giving a file to the path. It could be the shared location that we have specified during Docker run. It could be some web URI, NS3 buckets, whatever. And we can load that file into a Zeppelin, and it saves that into an internal object called dataframe. Data frames are just like tables, sort of. During this read process, Spark does its magic and actually discovers what sort of schema, what properties does this file has, and what can we search for. Because we've done 2 scans, I would like to query them at the same time. So I'm going to read another file, and you can join those 2 together in Spark and give it one single data source. You could just concatenate those 2 files as well, but just to show you how, some capacities of Spark. And the next thing that we're going to do is to actually create the table that we can query with SQL. And without any knowledge how that table looks like, we can just select everything, and this is our table from the Zeppelin, and it resembles the JSON file that you've seen. Every key is sort of a column with values of it as rows in a table. You can see that in components and pages there are some kind of arrays, because if you remember from the output slides, they were as a JSON output as a JSON objects. So we can also reference those fields in those sub-objects kind of in a similar way, just by prepending page dot and then the table name, the key name from here. And if we don't know what the keys are, then obviously we can run the query like that. Just to select everything from the page column, and then we're going to have another set of columns in here. So that's how we could discover the schema of the files that we have loaded. And now that we've got this file loaded, we can run all sorts of different queries and start answering the questions we've asked before. So we can run a query to count how many pages we have got in our 2 sites that we've scanned, and the answer is 594. And more interesting one is, okay, what components are we actually using on those sites, and how many times? So we can see that most used components is actually out of the box commerce image component with this number, and container components and everything, and that can give us an information if we're looking at an upgrade project, or try to assess the testing capability. That's very useful information to see that, okay, these components are used a lot, so we need to focus a lot of effort in testing them. But these components here, I mean, they're used 5 or 6 times. Are they really needed? Can we do something about them? Can we remove them? Can we join them with another? Can we restructure our page in such a way that we've got less components to worry about? And that gives us an insight on what can we do with those components. What other thing we can do with Spark is there are some information that we can derive from, for instance, the path or how the component has been structured. And we know, for instance, that content and first section is going to be our site name. It can be something different for your client, but let's just, as a convention, assume that our site or our brand is the whatever is under the second page level. And then the same would go for region, would be the third page level, and our language node would be the fourth page level. So this way, in our data frame, we'll have 3 different columns added with some custom logic as to how that is calculated. And we could then run some quite simple queries and group, for instance, number of pages by our brand, a region, and the language. And finally, we can create some other queries like, list only resource types, or list only components that are created on the page level. And obviously we can say components on a page level that come from only WKND site as well. So that will give us a different information. And the next interesting thing that we could do is, for instance, find out which assets are used from outside of our dedicated DAM folder. So in this case, we try to find out what assets are we using in our WeRetail site that don't come from the content DAM WeRetail site. This may be a requirement for your client or not. Sometimes you want to keep your content structure neat and just use the images from the folder that your site is used. Sometimes you want to reuse components, so it's not a static rule, but if you want to find out how that is used, is it really a problem? Is it happening on your platform, or is it not? Is it good? Is it bad? This just gives you an insight if that happens. And just here, we just have one instance of such image showing up. And obviously, we can count how many assets we use totally in our pages and reference. It would be nice to find out, for instance, how many assets we've got in total on our site. And for this, we can actually create something from AM out of the box. AM has got an assets capabilities, assets reporting, where we can create a custom report, custom files report, which will just print out everything from our, every path from our DAM repository, from the folder that we specified. And I've created one here. It lists all the assets that we have in on my AM instance, and we can download that report as a CSV file as well, which I've done already. So now we can also load that file into Zeppelin. Loading CSV file is slightly different. We still use Spark Read, but we need to specify a format. And because it's a CSV, it may have a header, it may not have a header. So we need to specify that our file does have a header. And if it does have a header, do we want to infer a schema? Do we want to use some schema that we already have in the Spark? So we're just saying, yeah, do your magic and figure it out. And obviously a reference to our file in a shared folder, and we're creating a second table, which is called assets. So right now we can run a query that says count our assets. Sorry, just to show you that the assets table is present there. So we can do select everything from assets and limit 5, and it will give us the title path. So this is our table that came out from the CSV file that came from AM. And so we can look at the path. This is kind of the reference that we've been collecting. So now we can count all the assets that come from that are in our AM installation, but the ones that are not referenced anywhere in the components table where we've located all the references in the pages and components. We can obviously print them, but just by removing the count clause, and we can see that these components actually belong to a different site that we haven't scanned, and they come from core component examples, and some from WeRetail as well, as we can see, are not being used on the WeRetail side as they are. So obviously we can count how many assets are there, and even though now that we have the data about the assets, we can actually make some good guesses about like what is the size of the assets that we would have to migrate along with the sites. For instance, if we're doing a cloud migration, you can figure out that, okay, we don't have to move all the 5 terabytes of our assets. We can just move, say, 30 gigabytes because that's what's used in our site, actually. And yeah, and obviously there are some other queries. And just to show you how quick it is, I've run the paragraphs again, but then you can see the timing in here that it doesn't really take long to execute any of these queries, and it's quite quick to execute any of those. So even though the traversal can take time, if you have really large repository, in practice, because you're not scanning your repository like the whole of the repository, you're just scanning your content tree. You're not scanning the version storage. Because you're also scanning the node store, you're probably not touching the data store as well, which usually is much bigger than the rest of the node store. So that scan is quite quicker, and all those operations you do in Zeppelin, they're completely outside of AM. So you don't need to worry about any kind of performance implications with running queries on your production environment, or having to download all of the content from your huge production environment to somewhere else to do the analysis. And that allows you to give, well, to do that analysis and drill down and interrogate the data that you're interested in as part of your analytics tool in here. Benefits are quite visible. I think you don't have to go through development process every time you want to answer some new query. If you've got the data already, then you can write the query. If you're missing a property, then the development effort would be add an extra property to your extract. And that's much simpler than creating another list, iterating over that again, and writing unit tests for that, etc., etc. It has a low AM impact. Obviously, it depends on the repository, and it depends on the breadth of your scan. So do performance test that before you run on production. But it's the technique doesn't have a big impact. Allows you to dive deeper into the data. So you may see some inconsistency. You're going to have a data that you're not interested in particular. So different people can be interested in different areas of that data. And obviously, you can compare that data over time. So between one extract and another, you can see what's the delta of your new pages between one extract and another. What's the delta in your component count, and things like that. And thing to notice is it only considers information from your AM repository. So if there is a component that you use and it doesn't leave footprint in your JCR, then that tool will not find it. So it is possible to have a component that is statically included in another component, and that it's just not part of the data repository. So it could show that actually you're not using that component anywhere, but in fact it does. Or you can have an asset in the DAM that is just loaded dynamically through your JavaScript, and then that's not going to be shown either, because what we're analyzing is the metadata in the JCR. I'm open to a Q&A. Obviously, the demo code that I've showed you is available on GitHub. Feel free to check it out. Any questions, just hit me up on LinkedIn, email me. But yeah, we still have time, so I'm happy to answer any questions you may be having. So I see there's one question. Yeah, the question is about that it doesn't have any branching strategy and any kind of no matching criteria. That's true. You could override the accept method a little bit further. And if you look at the source code of that method, it just blindly does a resource accept, and that because in this scenario we just want to scan everything, absolutely everything, because it doesn't really give you any. We want to catch all the instances of that, of those assets and all those components, but it's not really going to be a problem if we scan too much. It would have been a bigger problem if we would scan too little. However, if you would want to scan only pages that are under a certain path and don't dive into certain paths, then yeah, you would have to extend that class a little bit further. Yeah, I mean, if there are no more questions, thank you for attending. Give me a shout if you have any more questions, or if you try out and would like to see anything more interesting about how to use Zeppelin and how to analyze the data in your own content structure. I'm happy. I would be quite glad to hear from you. Thanks again, and enjoy the rest of the day.